To talk about conditional probability. This is day 4. We're going to do a pretty brief lesson here, but I do want to go backwards a little bit and talk about this cumulative frequency graph. This is not actual data. I did not take this from one of our tests, but I just thought, hey, why not? Right? Here are the test scores. Here is the cumulative frequency. I'd like for you and someone near to you to come up with the answer to these two questions. Approximate how many students score between 21 and 25, and then if 10% of students score higher than X points, estimate that value for X using this cumulative frequency graph. I haven't taught you how to do that, but I think it's kind of common sense. I just want to see where you're at with that. So give it a shot. If you get it wrong, you don't have to get married or something due to that. So just give it a try. We'll come back and we'll talk about the. Okay, so let's consider that there are 33 students in the class. Okay, and let's estimate that that's true. All right, I'll just do a horizontal dash line there to approximate that. And now let's move on to number 1. What did we say? Approximately how many students? 12. How'd you get 12?
21,
yep.
Many there was, and I subtracted it from what there was.
What did you estimate to be the number of students at that point for 21? 18. Okay, that's a good estimation. If you said 17, I mean, I wouldn't get too picky. Okay, so you said 18 students scored less than 21 or equal to, right? And then we went to 25? And what did you estimate that to be?
I think 30.
30? Okay, so 30 students scored less than or equal to 25. 18 students scored less than or equal to 21. Therefore, 30 minus 18 would be 12 students scored between 21 or 25, including them, right? So it's really actually pretty simple when you think about it that way. For this percentage, yeah, go ahead.
Is there one student who scored really low, and that's what it looks like?
Well, you could see the slope of the graph represents how many students at a given time are scoring, like up here, right? So this means fewer students are being added to the cumulative frequency. So less students scored that high. More students, I would say the most students scored right in this range, right? Because you can see the slope of the graph is changing at a higher rate. So then how would we answer number 2? Well, 33 students. What's 10% of 33? 3.3. Let's just say for the sake of the problem, let's say 3 students. Right? Let's say 3 students. So the top 3 students. What did the top 3 students score? Right? I went from 33 down to 30. So I would go from, I'd say above 25. Right? So X would be 25 points. Okay. Sound reasonable? There's a test question similar to that with different scenario. Okay. Okay, let's keep moving. I want to talk about this. Okay, so let's say on Saturday, 70% chance of rain, and on Sunday, we got a 60% chance of rain. Logically, if I were to see that, I'd say, well, there's better than a 50-50 chance that we get some rain this weekend. Agree? Yeah, ballpark. Yeah, above 50. Above 50. Okay, so here is where we get into some of the interesting probability stuff. And to be honest with you, I know some calculus teachers who, and it's not at this school, but at other schools, who will be tutoring pre-calc kids. And when those pre-calc kids come to probability, those calculus teachers say, no, go find somebody else for a couple weeks. Really? I'm serious. Probability is something that can like be a major pain in the side to certain people depending on how they deal with it. Okay, so part A, Saturday. Okay, so let's say it rains Saturday or Sunday. So if it rains Saturday, then it can't rain Sunday. So, right, Saturday, and I'll put not Sunday. That would be it rains only Saturday, correct? And then Sunday and not Saturday. So what would I do with those two? Multiply or add? Or means what? Add. Or means add. And means multiply. Or means add. And means multiply. What did he say? He said then. Then means this and then that. And then. Right? And means multiply. This or that. There really is no other synonym or whatever you say in English for that. So probability that it rains Saturday. Probability it rains Saturday is 0.7. Probability it doesn't rain Sunday is point what? 4. Then we're going to add that. I'm going to do this in a different color. Probability it rains Sunday is 0.6. Probability it doesn't rain Saturday is 0.3. Okay, now this multiplication can be done relatively easily. What's 7 times 4? 28, so that's 0.28. And 6 times 3, 18, so 0.18. So this is 0.28 plus 0.18, which is, go figure, less than 50% chance that it rains Saturday or Sunday. Weird. Okay, Saturday and Sunday, you should say thank you. Because what's the probability it rains Saturday? 7. It's 7. It's going to rain 700% of the time. Okay, Saturday and Sunday would be the probability that rains Saturday, 0.7, and Sunday, 0.6. So the chances it rains both is 0.42. 0.42. Now, the chances it rains neither, 2 ways to do this. We're going to cover all scenarios. What should all scenarios add up to? 1. So that'd be 0.888. So we should come out with neither being 0.12. Let's figure out whether or not that's true. So neither day, so that would mean not Saturday and not Sunday. So it's similar to part B in this way. Not Saturday is 0.3, not Sunday is 0.4, 3 times 4 is 12, so 0.3 times 0.4 is 0.12. And you'll see that all of those add up to 1. I want to talk about conditional probability. And what conditional probability means is this right here in words is the probability that A happens given B happens. I like to think of it as B has happened. Okay. Probability that A happens given that B has happened. Okay. And the way we would do this is take the probability of A and B and divide it by the probability of B. Okay. So first off, I want to show you a different way to find A and B if you're not given that. Let's say that we know that probability of A is 0.4 and the probability of B is 0.3 and the probability of both together is 0.5. Would you agree that the probability of A or B includes the probability of A and B? But there's kind of an overlap there, right? You got the probability of A, the probability of B, and then the probability of A and B. So the probability of A or B, I don't want to get too wordy here, is going to be the probability of A plus the probability of B minus the probability of both happening. Why? Because I don't want to count it twice. You with me? Okay. So if I want to find A and B, this right here, I could take these values for A, which is 0.4, and B, which is 0.3, and A or B, which is 0.5, and I could find this unknown. Okay, simple algebra from there will help us to find probability of A and B, because that's the key to this problem. I need to know that so I can separate up into the different partitions in the Venn diagram. So what would I do? I'd bring the probability of A and B over here, make it positive, and then take this 0.7 here and subtract 0.5, so it looks like I get 0.2. That's just a concrete way to do it. Yesterday I kind of just spit it all out, okay, but that's a nice way to do it to find A and B. So that connects A or B to A and B, which is great. So if I know that A and B is 0.2, and A is 0.4, then A and not B would also be 0.2. What would the probability in this sector over here, B not A, equal? 0.1, good. And so that means none of them would be 0.5. Now we can do some work. So now we can use this conditional probability that we just came up with. This right here will be the probability of A and B over the probability of B. Let's write each of these out. What would this one be? It's going to be a little different. Probability of what? B and A or A and B. Doesn't matter the order you put that in, but we're going to divide it by now the probability of A. And then this one here, probability of not A and B, which for some is hard to visualize, divided by the probability of B. So will you take 3 minutes and try to find those probabilities? We'll come back and we'll check, see how you did. Okay. Anybody back here? Adam, did you get an answer? Adam, Ben? I know for A.
Yeah.
0.2 over 0.3. Good. Yeah. And I'd rate that as 2/3. Good. All right. Probability of A and B is 0.2. Someone's going to do this. They're going to take 0.2 over 0.1. And it just, I mean, come on. Come on. Snipe. Right? Okay. How about B? Somebody? B? That was a Mark Wahlberg reference for those of you on the web. Liam?
Isn't it 2 over 2?
No.
No, 2 over 4.
0.2 over 0.4. Right? Did you get sniped? Yeah. The Wahlburgers, gotcha. They gave you the sriracha peanut butter burger. They did. Yeah, I get 1/2. I get 1/2, yeah. Okay, and this one is the one that a lot will get sniped by, but A and not B is 0.1. B is 0.3, so you should get 1/3. Okay, you should get 1/3 there. Okay, question number 9 is very important. We haven't covered this idea yet, but if you're given that the probability of A is 0.6 and the probability of B is 0.7, but you don't know A or B, or A and B, you got to be given more information in order to find the A and B. Okay? There is information given. What is it? They're independent. And here's a critical item. If 2 items or 2 events are independent, that means the probability of A and B is equal to the probability of A times the probability of B. Okay, that's the definition of independent events. For example, what's the probability of rolling a 1 on your first roll with a 6-sided die and a 2 on your second roll? They're independent because it's not like I'm taking marbles out of a bag and not replacing them. You see what I'm saying? If I replace or the odds are the same the second event, it's called independent events. Okay? So to find A or B, I would actually probably find B first, and then I'd go back and find part A, and then work my way through the rest of it. So just be aware of that. If you see independent events, probability of A and B will be the product of those 2 probabilities. Okay, I think that's it for today. This problem right down here with these creepy looking, I don't even know what, are those skunks?
No.
Trash monkeys. Okay. A raccoon is the kind of a trash monkey, so trash panda, that's much better. Yeah, this is the TP. That's the TP, the trash panda. Good luck with the homework. Give it a rip. It'll be fun. Tomorrow, if you show up, I guess this doesn't need to be recorded.